So in the class we learned that some numbers are So in the class we learned about different types of number systems, and in our context for this one, we will use real numbers as our biggest set. But in the lecture 15, I guess we are going to also introduce something called complex numbers. Now, the first question is every number you would see here a real number? Or even the better question is, okay, what numbers are not real numbers? Now, if you see an even root, for example, like a square root or a fourth root, or for example, you have a number here and this is an even number, that would mean it's an even root, and even root of negative numbers are not real numbers. So that would be the only clue that you can see and understand, well, this is not a real number. So for example, this one right here, it's an even root, it's a square root. We don't write this 2 here, and it's a negative number, therefore it's not a real number. So that's not real. Okay, and if you look at this number, again, the fractional exponent means that it's a root, but it's an odd root. So odd roots, any odd root is okay. So any odd root of any real number is a real number, so this number is okay, it's a real number. And again, when looking for what root, you are looking at the denominator of the fractional exponent. So now this one is again odd. Okay, therefore that means it's also a real number, so it's okay, it's a real number. And in the fourth example, you can see the denominator of the fractional exponent is even, which means it's an even root, and inside you can see a negative number. So it's an even root of a negative number, so it's not real. So these two examples, example number 1 and number 4, are examples of not real numbers. We will learn in a further topic that it's a complex number. Okay, and let's see, find the value of the following expressions. So as you learned in the lecture, if you have a parenthesis, this negative number gets multiplied by itself by 4 times. So what we have here is negative 3 times negative 3 times negative 3 times negative 3, and that would be, there are 4 negative signs, that means it's positive, and 3 times 3 times 3 times 3 is 81. So it's positive 81 in this case. Okay, and let's see how the other number works. It's again, you can see the negative is inside the parenthesis and it belongs to the exponent. Therefore, this is the same as negative 4 times negative 4. That would be plus 16, because there are 2 negative signs and product of negative times negative is positive. Now this example, you can see there is no parenthesis and this negative sign is just outside. It does not belong to this 2. So you just keep it here and you would do 4 times 4. That would be negative 16. So notice the difference between these two examples. In one there is a parenthesis, and the other one, the negative sign is just completely outside, it does not belong to the exponent. Okay, and the example 2, which I didn't do here, so that would be negative 27 to the power 1/3. Now we will do extensively about fractional powers in the lecture number 3. Now, but right now, just keep this in mind. So negative 27 is actually negative 3 to the 3rd power. Okay, because negative 3 times negative 3 times negative 3 is negative 27. And then you have that 1/3, and you can multiply these. So 3 times 1/3 is just 1, so you get negative 3 to the power 1, which is negative 3. Okay, so I would like you to do the examples or in WebAssign or in the homework that uses these properties and see for yourself how you would find those values. Okay, moving on. Okay, now so we will be learning a new number system called complex numbers. So this is kind of a future reference, but let me just write down all the number systems that we already know. We know the natural numbers, which is starting from 1, 2, 3, and so on. This is natural numbers. And when you add 0 to that set, that would be called the whole numbers. This whole set is called whole numbers. And then you would add the negative natural numbers and call that set. So let me just outline that in green. And you add negative 1, negative 2, and so on. And this set is called the integers. Now, once you have the integers, you can take fractions of integers, and the fractions of integers, the set consisting of all such fractions are called rational numbers. So that's a bigger set containing everything here, and those are called rational numbers. And as we learned, like things like 3/2, negative 5/7, and decimals that terminate, so 1.013. And then repeating decimals like 0.3333, or we would say 0.3 bar. All those numbers are rational numbers. And then we see that there are some numbers that are not rational, that cannot be expressed as this fractional form, and those are real numbers too, and we call them irrational. Okay, and the examples is square roots of not perfect squares like root 2, or square root of 3, or negative of square root of 5, or numbers like pi, numbers like e, some numbers like log of 2 that you will learn in the future. These are all irrational numbers. Now, these rational numbers and irrational numbers together make the set of real numbers. So this whole thing is real. So what are non-real numbers? Well, things that are square roots of negative numbers. So that would be the whole thing, and that would be called the complex numbers. So complex numbers starting with square root of negative numbers, and let's say you can add a real number and plus a square root of a negative number. We will call this in the future 5 plus root 7i, and these type of numbers are called complex numbers. And the complex numbers will be the end of our universe, because we would not go beyond that. And then this diagram should clear up any difficulties you have with picking which number goes where. Okay. Alright, so also you have learned how to express the statements in terms of inequalities. So let's see how that is done in these examples. So z is greater than -5 at most means it can be smaller, or it can be 4, or it can be smaller. So it should always be less than or equal. So at most translates to less than or equal. So z is greater than -5. So greater than -5 and is less than or equal to 4. So that's how you translate this sentence into an inequality. It says translate to an interval. So in interval notation, this should be, so -5 is not included. Z is between -5 and 4. So in between these, so it would be -5 to 4, -5 side in a parenthesis and 4 in a bracket because it can be included in the interval. One more example on that. X is less than 3. That's quite straightforward. At least, as we talked in the class, that translates to greater than or equal to. So at least is same as greater or equal to. So in that case, like that. So x is greater or equal to -1, but is less than 3. So you can also use the interval notation, and it's quite straightforward. It should be -1 in brackets and 3 in parentheses. Okay. And then let's look at the third example. Now the third example is different because it doesn't say something like x is less than. It says the distance between something is between two different values. Now let's work part by part. Now distance between x and 1, x and -1. That we learned in class that whenever someone says distance, you can just write d and write those two numbers. So in this case, it would be d of x and -1. That means the distance between x and -1. Now, as you learned in class again, distance between two numbers is the absolute value of their difference. Okay, so absolute value of the difference between two numbers, so x minus -1. Okay, and that would be just absolute value of x plus 1. So that's what we have when it says distance between x and -1. Now at most, again as we discussed in the previous ones, at most translates to less than or equal, and at least translates to greater or equal. So greater or equal to 1, but less than or equal to 3. So that would be how you show that statement as an inequality. Okay, now time for a question. So in a moment you will see a question and you should answer it correctly. It will have something like in this form, and you have to convert it to a inequality. Okay. So also in class we talked about absolute value notation. Now this is something that might be a little new to you, because well you might have seen the absolute value before. So again I try to explain what's going on here. What you do is you drop the negative sign, but mathematically we can't just say drop the negative sign. So what we do is, if the number is positive, you just use that number. If the number is negative, you would multiply that negative number with negative, so that you get the positive number, which is the same as dropping the negative sign. Okay, so this is what we ended up with. Now I'm going to introduce a very important notation. Okay, so let's just make it a star. It's a very important notation that I will keep on using. Okay, and the sooner you get used to this notation, the better for you. Okay, so this is what I would do. So let's say you are trying to find an absolute value of some quantity. Okay, that smiley face represents any quantity in there. That would be equal to this piecewise expression. So you look at what's inside, and if what's inside is bigger than or equal to 0, you will just write what's inside. Okay? And again, focus on what's inside. And if what's inside is smaller than 0, you would just write negative of what's inside. That's it. So remember the absolute value in this form, because I don't like to write absolute value bar and x inside, because that would just give you what would be the absolute value of x, and it doesn't give you an insight of what's going on. So let's see how we can apply that in order to when you split the absolute value. Now this is a word I use all the time. I will call this process as splitting the absolute value. So when I say, even in a class or in person, can you split the absolute value, I mean do this. Okay, so let's see. So write without absolute value the same as split the absolute value. So let's write this. Write the bracket or braces, and the same thing that's inside, just x plus 1 if x plus 1 greater than or equal to 0. If that guy is bigger than or equal to 0, and negative of x plus 1 if x plus 1 less than 0. So that's how you correctly split the absolute value. What's really important is this part. Okay? Now, you can just do a really quick simplification here. So the final answer should look like x plus 1 if x is bigger than or equal to negative 1, and negative of x plus 1 if x is smaller than negative 1. And that should be your final answer. Okay, and so once you can understand that single example, you should be able to split any absolute value at will. So let's do the second example. Now I'm going to go a little faster. So that is equal to just what's inside, 2x minus 1 if 2x minus 1 is bigger than or equal to 0, and negative of 2x minus 1 if 2x minus 1 is less than 0. Now do one quick bit of simplification here to get your final answer. You can send this 1 to the other side, so add 1 to both sides and divide both sides by 2. You get x is bigger than or equal to 1/2. So 2x minus 1 if x is bigger than or equal to 1/2, and then negative of 2x minus 1 if, so negative of 2x minus 1 if x is less than 1/2. Now can you distribute the negative sign and write it down? Of course, yes. And if the answer demands you to do that, you can actually do that. Okay, and the last one is this. Now again you have to split. But remember, you only split the absolute value. You don't split anything else. So, but when something else is there, you can just write it down as it is. You don't do anything to that, but you will split the absolute value. Okay, so that would be x minus 1. So that's the same thing inside the absolute value, and I'm writing what's in the bottom. If x minus 1 is bigger than 0, and negative of x minus 1 over x minus 1. So negative of x minus 1 would be because I am splitting the absolute value, and x minus 1 because I'm just writing it down. If x minus 1 less than 0. Now here you can notice that I did not write an equal sign here. The reason for that is if x minus 1 is equal to 0, I will be dividing by 0, and that is not allowed in math. So for that reason, I'm not writing greater than or equal to 0, I'm just writing greater than 0. Just notice that. And then, so you can see that you can actually cancel this off and you get 1 if x is bigger than 0, bigger than 1. And negative 1 because you can cancel these two off if x is less than 1. So let's do a quick graphing thing. How does this look like? And actually it looks like, so plus 1 if x is greater than 1, so something like this. Negative 1 if x is less than 1, so that part will look like this. So you can see it's a graph that looks like has that form. And this is actual graph, and the other ones are the axis. Okay, now one more question about splitting the absolute value. So answer the question you can see on the screen right now. So this is the end of the part 2 of lecture 1. I hope you enjoyed it, and look up for part 2 of lecture 2 on the next day. Thank you.